Hi, in this video, we'll discuss conditioned escape and avoidance. This chapter ties together the last 5 chapters and introduces our final unit on memory. First, let's take a step back and examine our innate emotional response. Emotion is comprised of conscious feelings, observable behavior, and physiological reactions. Regarding the latter, much of the research has focused on fear due to the relative consistency observed in fear responses both within and across species, although it's unclear whether other species have a conscious feeling of fear. Many species demonstrate an observable startle response or freezing behavior and other physiological responses such as changes in heart or respiration rate and release of stress hormones. The physiological and behavioral responses that accompany fear and prepare the organism to deal with the threatening stimulus are termed the fight or flight response. When the organism encounters a stressor, the autonomic nervous system suppresses the parasympathetic nervous system and activates the sympathetic nervous system. The sympathetic nervous system initiates the release of large quantities of epinephrine or adrenaline, which produces an increase in heart rate, increased blood flow to the muscles, pupil dilation, bronchial dilation, and decreased blood flow to the digestive system. In effect, blood and oxygen are diverted away from routine maintenance activities like digestion and immune response to prepare the individual for imminent danger. The limbic system plays an important role in the emotional response. The limbic system is a subcortical region composed of a variety of structures, including the thalamus and the amygdala. The thalamus is the primary relay point for sensory information. The thalamus receives sensory signals and then relays them to the cortex and the amygdala. The direct path from the thalamus to the amygdala helps to explain why we may have a rapid startle response before we've even fully processed the stimulus. So for example, one time I was at the Parks Mall and I was waiting for the elevator, and all of a sudden I heard this loud pop behind me, and almost immediately, right, I duck and I scream. And then it's a few seconds later for the information from my cortex, that indirect, slower process. A few seconds later for that information, this more fully processed by my cortex to reach my amygdala, for me to realize, oh wait, based on the context, the ice skating rink is right behind me, people are playing hockey. That loud pop was a hockey puck hitting the plexiglass rather than a gun. And so then I realized it was silly for me to scream and duck, and I look around me and observe that that is not socially approved of to scream in a crowded mall. But my initial response, right, that quick response of information sent to my amygdala directly, that information was not fully processed. And so we may have that rapid startle response before we have received the full information from the cortex. The amygdala is important in both learning and expressing emotional responses. The amygdala is key to producing a conditioned emotional response like the one produced in Little Albert. Remember that John Watson repeatedly presented the conditioned stimulus, the white rat, with the unconditioned stimulus, the loud noise, until Little Albert demonstrated a conditioned fear response to the rat. Lesion studies have shown that bilateral damage to the amygdala inhibits the conditioned response. Specifically the conditioned fear response. Through recording and selectively activating neurons in the amygdala of rats, researchers have discovered that the basolateral amygdala is responsible for learning the conditioned fear response, while the central amygdala is responsible for producing the learned response, actually responding to what has been learned through conditioning. So we see the basolateral amygdala and the central nucleus of the amygdala. In escape conditioning, we can examine the fear response from an operant conditioning perspective. The subject learns to produce a response that eliminates the feared stimulus. For instance, a rat learns to press a lever to stop an electric shock. Lever pressing increases across the trials due to negative reinforcement. Something aversive, the shock, is removed, which is perceived as desirable. Similar to the example of taking aspirin when you have a headache. That behavior of lever pressing for the rat or that behavior of taking aspirin for you increases in the future because of negative reinforcement. It removes something negative from your environment, which is perceived as rewarding or desirable. So we see an increase in that behavior. If we take fear conditioning a step further, we can combine operant and classical conditioning to produce a learned avoidance response. First, a conditioned stimulus is repeatedly presented alongside the feared unconditioned stimulus to produce a conditioned fear response. Then negative reinforcement is used to produce a learned avoidance behavior. For example, we pair an electric shock with a visual cue like a light until the light elicits a startle response on its own. Then the rat is taught that by pressing the lever or here, using the door to go into the other chamber, the shock will stop. If the rat can use the light as a predictor for the shock, it can press the lever or escape to the other chamber, thereby preventing or avoiding the shock altogether. So if it can press the lever or run into the other chamber as soon as it sees the light before the shock is even administered, it has avoided the shock completely. So if we go back to our aspirin headache example, if you always get headaches when it rains, then the rain is that conditioned stimulus or that cue that you can use to predict a headache. Then you could take the aspirin as soon as it starts raining, before your headache has even started. This could be an example of avoidance conditioning. And this example is consistent with the cognitive expectancy theory of conditioned avoidance. The theory is that the subject weighs likely outcomes of a response when deciding whether or not to make the response. Is taking aspirin likely to prevent a headache, thereby being rewarded through negative reinforcement? Maybe, but only if it's raining. Of course, this explanation references the underlying mental processes like decision-making and cognitive expectancy that behaviorists argue don't exist. The behaviorist explanation is that the negative reinforcement for lever pressing is the removal of the conditioned stimulus, the light that is now feared. It's not necessarily the removal of the shock, because that never comes. Instead, it's that lever pressing or escaping to the other chamber removes the conditioned stimulus that is now feared, the light. The rat presses the lever to turn the light off, not explicitly to avoid the shock. But theoretically, there are some problems explaining avoidance conditioning from a behaviorist perspective. Given what we know about extinction, if we remove the aversive unconditioned stimulus, the shock, then over time we should see a decrease in the conditioned response. If we avoid the shock, the light is no longer reliably paired with the shock. So through the lever pressing, our rat has disrupted the association between the light, the conditioned stimulus, and the shock, the unconditioned stimulus. So if there is no reliable pairing of the light with the shock, then there's no reason to fear the light. If the light isn't feared, then why is the rat still pressing the lever? So this is difficult to explain from the behaviorist standpoint, this two-factor theory of avoidance conditioning. Read more about this controversy in the book to decide which explanation you support. And we'll talk more about the role of emotion in the memory process.